The next one from the book. Given the following strengths, okay, find the maximum value of the objective function. The objective function is going to look like this. C equals 3x plus 2y. We're going to go through this whole process once, and then see how it goes. If you do have a question along the way, like if I spelled something right about it, ask me. I may say hold your question, but ask me. Yes?
Okay, like when it says like y is like whatever.
Greater than 0.
Greater than 0. That's greater than 0. It's not.
This is a C, yes.
Is that like a piecewise function because it's like where it can go in between?
Now, if it were a piecewise function, it would have y or f of x equals out here, and it would only have x's over here. This is a system like we were solving on the last test. This means graph all of these on the same plane and find where they intersect.
How do you graph y is greater than 0?
Glad you asked, because we didn't actually do an example of that last time. May I erase this board?
Yeah, sure.
Everyone have it. Excellent. Okay. Now, some of this... Yes, Mike? That's a really good question. Okay, hopefully I can give a really quick answer. That's supposed to be y. Thank you. That was a typo. I tried to comment that yesterday. Thank you for asking. Okay. Okay, first thing we have to do is graph this. Now, Amanda's got a good point. We didn't do any examples of those. We did other examples of horizontal and vertical lines.
Oh, we have to graph these?
Yep. Shocking, in Algebra 2, you're going to be graphing lines. Yes. Make sure I get it back. I need all of them for a test. Who needs a ruler?
And a pencil. I need one.
Wait, why didn't you do it?
Anybody else for ruler?
I need one.
In this math class, we use this. Exactly. Amy, you also said a pencil?
Please don't do it, please don't do it, please don't do it.
Attempt to do just for the reaction. Will you hand that to Nimi, please, Amanda? Thank you. Okay, now, before I start shading something, I'm going to teach you guys something a little bit different this time. Okay? Think about what this means in English for a sec. Amanda, you asked how to graph this. Okay, remember, these are inequalities. That means you graph a line, and then you shade one side or the other of the line, right? Okay? What does the line y is greater than 0 mean?
Greater than 0.
Greater than 0. What part of the xy coordinate plane does that represent?
Positive.
Positive what? You got positive y's and positive x's. Which one does that represent?
Positive y.
Positive y's. So if I just asked you to graph that inequality, I would be saying shade everything above the x-axis, because that's everywhere where y is positive. Hang on, don't shade that in though yet. I'm just going to put a little arrow down here to kind of indicate that that's what I would do.
Should I do that?
Not yet. Wait till I'm done on this. Do me a favor and wait till I'm done on drawing this one, because you may want to. It may affect how it goes on your paper. Similarly, if I'm talking about the area x is greater than 0, okay, which two quadrants would I shade to represent the idea x is greater than 0? Remember my quadrants? Quadrant 1, 2 is over here, then it goes 3, then it goes 4. 1 and 4. Because the idea that where all the x's are greater than 0 is over here.
No.
So we know it's going to be in...
Yeah, actually. But,
No, I don't.
Pardon?
What are you doing?
Okay, I'm pretending to shade everywhere where x is positive. Okay, now Phil just had a point. These two concepts, the only place where both these ideas are going to be true are in the first quadrant. Because where's the only place where y is greater than 0 and x is greater than 0?
Just use the arrow.
Pardon? Where's the only place on this graph where x is greater than 0 and y is greater than 0? The first quadrant, Becca said very quietly. Okay, so yeah, right now we know where our solution area. Remember, these linear inequalities, hey, it's okay. These solution inequalities only have the double shaded area right now would be quadrant 1. Yes?
So they intersect.
Well,
because the shading matches.
yeah, the shading matches. We're shading both. See, basically, I want you to wait a minute. So on this one, I don't want you to shade everything and then look for where you've shaded 4 times. I want to only shade where all of this is true. It'll be a lot less messy that way. Okay? Now, very quickly, because we've done a lot of these, x plus y is less than or equal to 10. What's the fastest way to graph that? x plus y is less than or equal to 10, what is the fastest way to graph that?
Would you plug in points first?
Which points would you plug in?
X and Y?
A little more specific. What would I plug in for x or y?
Oh,
0?
Zeros. Make this table. For God's sake, make this table. Okay?
What do you,
When x is 0, what is y?
10.
And when y is 0, what is x?
10.
Okay, so if I give you a line in standard form with the numbers that simple, I really need you guys, on the next test, I'm only going to plan that it will take you just a couple of seconds to go, oh, this thing hits at the points 0, 10 and 10, 0, and it'll look something like that. Now, why did I, pardon?
excellent line.
Thank you. It's my best freehand line I think ever.
Can we do that right now?
Give me one more sec before you do.
Okay.
Now, why did I stop here and here?
Because you don't want to go through because it ends there?
It ends there. I've already been told my area where that I'm going to be describing is where the y's and x's are greater than 0. Very good, Nimi. I already know I'm only going to be dealing in quadrant 1 because of these two constraints.
But is that actually, I know for the purpose of like the exercise, you're saying it ends there, but does the line actually stop existing after those points?
This line, no. This line independently goes by itself. But we are looking, once I put this bracket around a bunch of lines, and we're talking about a system, and this system does not exist except in quadrant 1, as you put it so well. So as long as this line is part of this bracket, this is a true statement. If I take this line out of this bracket, you're correct. It's no longer a true statement. It should go on forever. Yes, Amanda?
It's like a piecewise function because you can't go like past where it says like past.
That's a good point. It actually is kind of like a piecewise function. We're keeping all our dogs in this yard now. Okay? But I don't want you to get confused on the how-to, on the process of a piecewise function with this, because that's different. But conceptually, you're right. It is similar, because again, you're constrained. You can't go anywhere. This one's a little bit more annoying, I admit. 2x plus y is greater than or equal to 13.
2x plus something.
2x plus something. 2x plus nothing.
Wait, would you
It's a Zen Buddhist problem.
Would you plug in zeros now?
We can do that and we'll get a fraction. I don't mind doing that and getting it. I still think it's faster because now we put in a 0 for x. What is y?
0. Oh.
This was supposed to be less than. I greatly apologize. This was really supposed to be less than 13. It's supposed to be less than in both cases. Please change that.
What are you doing?
I deeply apologize.
Oh yeah, you're right.
It has to be. Yeah.
Point to where it's supposed to be. Oh, you did. Just kidding.
Point to the equation right
Okay,
now.
point to the equation. Yeah, just point here. These are both supposed to be less than, and I miswrote it.
Where?
Yes, thank you, Rodney. Get that on the
Wait,
film.
Mr. Bell, how can you?